Hi again. Okay, my next presentation is going to be regarding sort of scheduling and planning and status control in the model. But before I go any further, I'm just going to show a few other little bits and pieces. I think I've got 30 minutes, yeah? Yeah? Yeah.
We eat some.
Oh, I know that. So I can always be quick with this kind of stuff. So I just want to expand a little upon what we've been showing from the Tekla model to the CNC, to the V-shaped CNC machines. So let me just give you a couple of little examples. So let's put a steel beam in here, just to throw something very, very quickly together. So steel beam here, and I'll put a beam between them. So just from mid to mid, so you can see the connection we're putting in there. I'm going to put on a very specialized connection here, which is an offshore one. This connection, of course, contains a lot of copes, weld preparations, and things like that. So I'm just going to put on the standard one. So if we say this one connects to this one, again, it looks at the two pieces and sort of welds and prepares them together. So that's a more complex connection. You can see that. So you can see there, look, the weld preparations, they're called mouse holes, and all the way through that like so. So even for something as complex as this, we can download that directly to the V-shaped machines. Let me just give you a little look at the example of that. Let me just expand this out. So these are now automatic coping robots. So you can see here then that the information for all the weld preparation and everything is all the way down from the Tekla model. Let me just skip that on a little. Maybe I skipped that too far actually. Let's take a look. So here then you can see that then the robot cuts the piece of steel exactly as it's been defined in the Tekla model. So it's not just for standard bolted connections, for drills, for marking, it's all for very, very complex 3D geometry. So you can see, quite interesting. So the way the industry is moving forward. That's the same for, let's say, tubular sections. So if what I'll do, let's just click on here first of all, put a beam in there. What I'm going to do is I'll click on this, and I'll change this into a pipe diameter, let's say 500, let's put caps on there actually, pipe diameter, yep, let's say 500 by 50 millimeters thick. So now it's a pipe. Okay, so you can change these profiles into anything you want. Let's put that about the center, so now I've got a pipe there. Let's pick that one up, and we'll say let's copy that from here to here, and then again we'll draw a pipe between them. So we'll say I want the beam. Again, from midpoint of here to this point here, I'll click on this one, and then we can say copy the properties and make that one the same. So nice and easy just to copy them across as well. I'm just going to click on this one here, and I'll change this, let's say, into 400, like so. Then for the connection on this particular one, we've got specialized tube connections. So it's not just for regular beat, it's for any kind of connection. And we can say this one, so that pipe connects to that pipe, and it will weld the two together. So let me just change the colors slightly. Click on this one. You can see then there, that has got preparation on there, like so. So typically what a drawing office has to do is create the unfolding drawings. Now we can do that in Tekla as well, but we can link these down directly to three-dimensional cutting robots for pipes. If I just show you that one. Should I put that on there somewhere? Just bear with me. I might have to just jump out. Let me just go back here, D drive. Here, just bear with me while I find the correct video. So, HGG. Okay, and let's just go to the movies. Oops, sorry, it's actually in the root of here. Bear with me. So then if you just find the 600 here. Where are we? Here we are. So then these machines are similar, but what they do is they actually do the pipe cutting in 3 dimensions as well. Again, let me skip on a little bit more. So you can see here, look, then the pipe cuts in 3 dimensions based on the Tekla model. So when those pipes fit together, you can see then there's absolutely no other preparation needed. Like so. Yeah, it's not quite that quick, it's a speeded up video, but just to give an example. So there we are, just a few other sort of more complex examples. So as well as your basic machines, well, they're not basic machines, but as well as your standard machines, these are also complex three-dimensional cutting. Everything we do here in the model will automatically, you saw the video Vladimir showed of the Zeeman machine which automatically assembles. That's all based around the Tekla model as well. So export the data, the automated machine will put that piece together as needed, as required. Okay, so just bear with me. Just go back to my presentation. Quick access, Belarus. Let me just go to my status, like so. Right, so just talk first of all about the sort of status and tracking on here as well, because as the project is going through the workshop, people like to know what's actually happening, so the feedback can come back to the Tekla model as well. So what we do there is, of course, you can export that out, so you get all, so you can actually then do the erection sequencing, so the status of every single piece as it goes through, and of course all the listings, etc., as I showed you before. But if I just run through here, you can see then as it goes through the software, it actually tells Tekla where it is in the model. I want to find some videos, actually, bear with me. So this is the video that Vladimir showed. So you can see as it's going through the factory then, what happens is, as it's running through the factory, it color codes the Tekla model to show you exactly what the progress is on the Tekla model. Like so. So then you can visually see the status of exactly what's happening in the factory. Just run through here. So what I'm going to do then, let's just open up an example. If I show you an example here, this is one that was done with Fichette machines actually. Just open this model up. So if you take a look, that's a model here. If I click on a piece, you can see then we've got the attributes of the date that each operation happened on. So you've got fabrication, you've got CNC, you've got welding, you've got painting, you've got shipping. Hopefully I'm not going too fast with my translator. And then what happens, we can then say, okay, show me a timeline of what's happening. So we can go to the manage here. I'm actually just going to go to the wrong one actually. Sorry, bear with me. Let's close that down. Project status. Then what we have on here is you have, just load this in. Load it. Then you've got the color codes. So you can see there you've got a color code: red is being shipped, blue is being painted, welding, and so on. So that's the color codes I'm using. Then what we can do is we say, okay, load that in like so, refresh the screen, then you can step forward a date. This was done back in September 2016. But as you step forward a date at a time, you can see then on this particular day, these pieces went to fabrication. And then green, they've then gone to welding. So you can see then the color code of what's happening all the way through the shipping progress, like this. And then finally, the red pieces have all been shipped aside. So you have the sort of mobile application that Jeffrey showed you, on where you can actually see what's happening just as some numbers, or you can visually see it on screen as well. Let me just go back to standard colors to load it in like so. Does that make sense? You know what I'm saying? So as it goes through the factory, the data is put to the model, you can then visually see the status of what's happening in the factory on your Tekla model. So that's the way that's all been used like so. Just open up another model. Here we are. Okay, bear with me. Just going to open up this model. Let me just go back. In Tekla as well, we can also do the scheduling and planning, which is what I'm going to show you next. So within Tekla, you can do the scheduling and planning, and you can link that out to standard softwares as well. So within Tekla, you can plan your timelines, your dates, when things are due to be manufactured, and you can link it to any standard scheduling software that you may have as well, or use it as a standalone scheduling software. So we're back to the same model. Here it is. So if we're going to manage them, within Tekla here, you've got what we call Task Manager. Then this then is my scheduling and planning software. So what I'm going to do is I'm just going to change a few options here. So I'm just going to settings and say stay on top, which it is, which is good. And I'm going to say view wise. I want to view as weeks, which is fine. So what I can do then is I can create a new status and I'll say, okay, this is my project, like so. And then beneath that, we can say, okay, I'm going to have, first of all, let's say the columns. I can, let's say, beneath that, I can have, let's say, the beams. And let's say beneath that, I can have the bracings. So a simple timeline. And you can see here then it's created the timelines over here. So I can pick on these pieces, I can drag them to be the sort of times and dates that I want. Like this, just move them around. Like so. So nice, easy way. And this is all part of standard Tekla. So there's nothing that you wouldn't have if you got the software. Let me just shrink this down a little, like so. Just go on here just so I can see those timelines. Then what I can do is I can then say, okay, columns. I can go to my model and I can say, okay, this column here, and this one, and let's say this one belong to this timeline. So add selected objects. So those now belong to that timeline. Right? And then I can say, okay, let's say these beams here. Just doing a little simple example for you. Let's do a few more. These belong to the beams timeline. So let's say add selected objects. So they now belong to this timeline. And let's say finally then some bracings. So let's say these bracings here belong to this timeline. So we'll say add selected objects. Now, at the moment then, what I'm doing is I'm guessing, or I'm sort of calculating manually how long it's going to take me to make those bracings. But you can then put in calculations. So you can say, okay, put in what we call task types. And let me just remove the ones I've got here. So I can say, look, these are like mathematical calculations. So I can say, right, look, paint. And I can say, I can paint, let's say, area, not pieces. You can do it by many different calculations. Let's say I can paint 5 meters squared every hour. Okay, that's just a calculation I've added. There we are. And I'll add another one, which is, let's say, fabrication. And this is manual fabrication, nothing to do with the machines. And I can say, look, my factory can make, I can do this by weight, let's say pieces. I can make, let's say, one piece every, let's say, 4 hours, which is a pretty poor calculation, by the way, but there you go. So you can modify that, like so. Then what we can do, let me just get rid of that time, there we are. Then what we can say here now is we can say, rather than guess these timelines, just good task type, you can say the columns look here, and just drag this along so you can see more of this, and drag this back. So that's the timeline. So I'm guessing this, but I can then say, using that calculation, look at the pieces in the model and actually work out how long it's actually going to take me to make those pieces. So then we can say, look, how long is it going to take me to paint these pieces like so? And if you click on there, it'll automatically, let me just check on this. Say scheduling, there we are, like so. So forwards and backwards, so only forward, like so. General, just bear with me. Scheduling, fixed start and end, so it's just a fixed start point. If we say okay to that, so if we go back to this one here, paint calculation, it will automatically do the calculation. It will tell you how long it will take to paint those pieces based on the model itself. So it will automatically work out the timeline for you. And then you can say to that, let's export that out. You can take it out to either Microsoft Project or Primavera, so you can link it to your existing scheduling software as well. So I could now say, I could do a schedule saying, how long is it going to take me to fabricate that job? Then when I get the feedback from Steel Projects and FSHEP, it will give me the actual timeline. Then I can compare the two. So you can have a schedule, and you can have the actual. So you can get the real calculations for the job before and after. So let me just clarify some of that stuff. Let me go back to this PowerPoint. Oops. So what we can do then within Tekla is you can also say you can do your planning of how it's to be erected using the same software. So you can say the installation is this piece followed by this piece followed by this piece. And that tells the guy on site how he has to put up the pieces, how it's to be erected. Ignore that one. Then we've got this task manager, which I just showed you. So you can do all the different calculations, look, and you can break it down as you want to do it, and then it will calculate automatically how long it will take to do that job for painting, for fabrication, for welding, based on your calculations. And you can have these calculations as many as you want. You can do as many timelines as you want. So you can do that and then accurately calculate how long it's going to take the job based on the model itself. If the model changes, let's say that the surface area becomes bigger, then the timeline will automatically adjust itself. And again then, as it's running through, so that's really how it's changing the way things are working. So the model is not just for detailing anymore, it's also for production planning. It's allowing you to do the traceability of everything that's happening in the workshop visually and by report. This is an example of one that was done. So this was fully managed, this project, and it was 3,200 tons, more than 15,000 assemblies, and it was erected over a period of 3.5 months. And a project from Macedonia, which was actually detailed in Greece, by the way. So your task manager here, again, just to reiterate this, you can see then all the pieces here, the timelines. We can do the planning to the workshop or any other kind of planning that you want to do. And the data is always fed back to the model. Again, runs through there, feeds the data back. As it's going through the factory, really high technology factories have got like a touch screen within the factory, so they can touch on a machine as well and see the status of what's happening real life in the factory. So the guy, where's the point? So the guy in the factory then, say this machine is this here, he can just touch the screen, he can see exactly how much went through that machine that day or that week. So visual tracking within the workshop as well. There's only a few companies do that, but it does happen. And again, as it runs through the factory, it color codes the Tekla model, tells you the status of where everything is. And that feeds back into our scheduling software, which again links to Microsoft Project or your software. Again, my task manager here, you can see then, when it's in the tasks, that's the piece in the model, that's the time it's going to take to paint or weld or do anything with those pieces. That's all, everything I've shown you here today, everything. The specialized connections, the links are all part of the standard program. There's nothing extra you have to buy, it's all part of standard. Skip that one there. Again, this is just linking out to Microsoft Project. And just an example in South Africa of one project that was run through as well. So this was fully managed, detailed, sent to steel projects, done on V-shape machines. HGG pipe cutting, that's why I showed the pipe cutting, so you've got pipe-to-pipe connections here as well. So this is a full flow that was done on this particular project here. Just one last presentation, well, one last PowerPoint actually, and it's this one. We've got a small calculation here. Let me just show you. It can be a little difficult to explain, but pretty much is, if you had a copy of Tekla, how long would it take to pay for itself? You know, when would you see a return on your investment? So we did some calculations actually. And these calculations are based on just drawing production. They're not based on scheduling. They're not based on linking down to CNC machines. So this is just based on drawings. So if you did a simple drawing, a model with simple drawings, okay, that's a simple structure, let's say. You've got sort of the sort of average rate that you pay a sort of draftsman. This includes, of course, the whole cost, not just his wage. So how much it costs to have a draftsman sat in an office, and how much the license costs, and how long would it take then? So really, we calculated then you could save every week the hours saved. Then if you add that up, we calculated that you could see a return on your investment on the Tekla license in 43 weeks. So if you bought a Tekla license, it would pay for itself in 43 weeks. or 10 months. This is actual calculation. It's not done by me as a sales pitch to you guys, don't worry. And then we did another one, which was based on more complex modelling. So let's say really complex structure. And then we actually calculated that the return on investment for Tekla Structures was, or if you did 1.5 projects, it had paid for itself. So these are nice figures actually, or 2.1 months on complex, because the return on investment is greater on complex structures than simple structures. So it's some actual facts and figures of what you can expect from return on investment. With model sharing, this is where we can share the model around the world. Let me just find the calculation here. We've got a calculation on this as well, where if you use model sharing, this means you're sharing your model with people around the world, or even internally, that because the waiting time, if you're on a regular network, the waiting time to save the model over the network or to actually save the model for somebody else to work on it, if we work out all these, the waste of time that happens, so we calculated how much you have to wait for every numbering for somebody to save the model. This is within a network. Then if you use model sharing compared to this is the actual savings that you can make in minutes. And then we calculated per day, if you've got like, I think this was based on something like 15 users. So 15 copies of Tekla, you saved almost $2,000 a day just by using model sharing. So, and that actually translated into over the year, it translated to $78,000 just using model sharing. So it's nice to have some actual facts and figures there that you can refer to. So there we are. Let me just go back. So again, this is Tekla Structures. This is, if you get Tekla when you install it, this is exactly what you get, everything I've shown you here. It's in multiple languages. It's multiple interfaces. All the standards are in there already inbuilt. It's just ready to go straight from the box. So again, that's Tekla, like so. Okay, thank you. That's my final presentation.